Hello friends, this is the fifth video in the CSES sorting and searching video series. In this video, we will be solving the problem number 5, which is restaurant customers. The problem statement is, you are given the arrival and leaving time of n customers in a restaurant. What was the maximum number of customers in the restaurant at any time? Input, the first input line has an integer n, the number of customers. After this, there are n lines that describe the customers. Each line has two integers, a and b. The arrival and the leaving time of a customer. You may assume that all arrival and leaving times are distinct. In output, we have to print single integer, the maximum number of customers. Constraints are n is greater than or equals to 1 but lesser than or equals to 2 into 10 raised to power 5. Basically, our solution should be in worst case n log n. Then a should be greater than or equals to, a is greater than or equals to 1 but lesser than b, while b is greater than a and lesser than or equals to 10 raised to power 9. Then we are given a sample case. First, let's discuss what the problem statement is. In the problem, we are simply given n customers which arrived in a restaurant at distinct times. Then we are given n pairs which are arrival and departure time for all the n customers. Firstly, we are given an integer for every customer which is arrival time, and then another integer a departure time or the leaving time of that customer from the restaurant. So what we have to do is we have to find out the maximum number of customers at any particular instance. That what would be the maximum number of customers in this restaurant at any instance. So how we would approach this problem? Let's first see the test case. So this is the test case given to us. We are given 3 customers, of which first customer arrived at 5 and left at 8. Then second customer arrived at 2 and left at 4. Arrived at 2 and left at 4. Then the third customer arrived at 3 and left at 9. So what would be the maximum number of customers at any instance? Let's say this is our maximum customers. Let's say max C. So max customers at any particular instance would be at time 0 and time 1 there is no customer. Then at time 2 the first customer arrived. So the number of customers at time 2 is 1. Then at time 3 another customer arrived. So the number of customers at time 3 is 2. Then at time 4 these same 2 customers are in the restaurant. There is no new customer. So the number of customers is 2. At time 5 this customer 2 he has left the restaurant. So the number of customers are 1 but another customer arrived at time 5. So at time 5 also we are having 2 customers. One customer left at time 4 but another new customer joined at time 5. Then till time 8, from time 5 till 6, 7 and 8 the number of customers remained same, 2. Then at time 9, since the first customer left at time 8, so at time 9 we have 1 customer. So the best answer from all these answers is 2. So the maximum number of customers are 2 for this case. Let's discuss another case. So let's discuss this case. So if there are 6 customers, first arrived at 2. Now then he left at 10. So 1 second. Arrived at 2, left at 10, let's say. Then the second customer arrived at 6 and left at 8. Then the third customer arrived at 5 and left at 11. Then the fourth customer arrived at 1 and left at 3. Then fifth customer arrived at 7 and left at 9. Left at 9. Then 5 to 6. The last customer, the sixth customer, arrived at 5 and left at 6. So the number of customers at any particular instance. At time 1, the number of customers is 1. Then at time 2, another customer arrived. So the number of max customers, let's say it. These are the MC, max customers at any particular time. At time 2, the number of customers are 2. Then at time 3, the number of customers are still 2. Those same customers, there's no new customer. At time 4, no customer arrived. But this customer which was at time 3, he left. Which came at time 1, he departed at time 3. So at time 4, we are having only one customer. Then at time 5, we received 2 new customers. So our customer count became 3. Then at time 6, we have another new customer. So the number of customers became 4. Then at time 7, this customer left the restaurant, but another new customer joined. So one customer left and one customer joined. So the number of customers remained same, 4. Then at time 8, again we are having 4 customers. But at time 9, this customer left at time 8. So at time 9, we are having 3 customers. Then at time 10, this customer has left at time 9. So at time 10, we are having 2 customers. Then at time 10, this customer left. So at time 11, we are having 1 customer. Then at time 12, we are having 0 customers. So the best answer is 4. Now how we would approach a solution for this problem? Let's see how we can form our solution. So one approach which we could use is that we sort all our arrival times in ascending order. Let's say these are our arrival times. We sorted them in ascending order. So the least arrival time is 1, then second least is 2, then we have 5 2 times. So 5, then again 5, then 6, then 7, and then all our 6 customers are received. So then similarly we would store departure times as well in ascending order. Let's say the first departure time is 3. We don't care that they are paired together or not, because we don't care about which customer arrived and departed at which time in combination. We just want to know the number of customers at any particular instance. So we don't have to care about indexes. 3, 6, then 8, 3, then 6, then 8, then we have 9, 10 and 11. 9, we have 10, and we have 11. Now what we could do is, when this customer departs, let's say it first customer, because he is departing before any other customer. So when the first customer departs, if we would know how many customers are there in the restaurant, we could easily formulate our answer, the number of customers at current. So when this customer departed at 3, if we find upper bound for this in arrival array, in arrival vector, if we find upper bound would be 5 for the 3. So this upper bound indicates the first customer who arrived after the departure of this customer. So after that, if we decrement our iterator, we can come to this customer who is the last customer who arrived before the departure of this customer. So this is the last customer. 2 is the arrival time of the last customer who arrived before the departure of this customer. So that means the number of customers starting from beginning till here are the customers who arrived before the departure of this customer. So basically this is the answer for time 3. So we can see the maximum customers, the maximum number of customers when this customer departed before the departure of this customer is 2. Why? Because this one and this one, these two were there in the restaurant. Now one of these is departing, but we don't care who is departing, the one who arrived at 1 or arrived at 2. We just care that 2 customers arrived, then he is departing. So the maximum number of customers are 2. Then after that, we will find upper bound for 6. For 6, the upper bound would be, for 6, the upper bound would be 5. Sorry, for the 6, the upper bound would be 7. So this is the first customer who arrived after the departure of this customer who is departing at 6. So if we will decrement our iterator by 1, we will get the last customer who arrived before the departure of this customer. So basically this is the, so the number of customers who arrived before the departure of this customer is 1, 2, 3, 4 and 5. These 5 customers. But the answer won't be 5 for him, because one of these 5 customers who arrived before the departure of this customer has already departed, which is this one. So the answer would be 4. Then for 8, this pointer would point to the end of the vector, because the upper bound of 8 is the last element of vector, which is, let's say this is the end of the vector, the last location which is not a valid element, that would be the upper bound for 8. When we will decrement our iterator, so iterator would be pointing to this 7. That means 6. There are total 6 customers who arrived before the departure of this customer, but from these 6, these 2 have already departed, so it would be 4 again. Now how we are getting this answer? If you would think once, we are finding the upper bound, the iterator we are decrementing, then with the help of iterator we would find the number of customers, but we will decrement I from it. I is the index of this particular customer who is departing. So that index is indicating the number of customers who have departed before him, because in indexing we always have the index is always 1 lesser than the position of the element. So it would be IT minus I. Let's see how we would approach the solution for this problem. So in this way we would approach. Firstly, we will find upper bound for the departure of this particular ith customer. This ith customer's departure time, we will find upper bound for it in arrival array. Then we would decrement that iterator, because this iterator is currently pointing to a customer who arrived after the departure of this customer. We will move to the previous customer, which is the last customer which arrived before the departure of this customer. Then we would find our I customers who have arrived before I. We will find all the customers who have arrived before I. How we would find that? We will find that by subtracting the beginning index of beginning iterator of the array from the IT, which is the beginning iterator of the arrival array. That would be subtracted from IT, because that would indicate the number of elements till here. We will add 1 to it, because in programming, indexing is always 1 lesser than 1, so we would be adding 1 to that. Then our current customers would be, what would be the count of current customers? That would be these arrived before I, these all customers who arrived before I minus I, because from these customers who arrived before I, some of the customers have already departed, and what are the number of those customers? That is I. So let's see how we will write the code. Firstly, we will take n for n, the number of customers. Then we will create two vectors of size n. One is for arrival of customers and another is for departure. Then we would sort both the arrival and departure array. Let's take them in long instead of taking int. We would sort both the arrival and departures. Then we will take a long type variable max customers, which would store maximum number of customers. It would be initially 0. Then we will run a loop. We will take our iterator IT. We would find upper bound for arrival dot beginning and arrival dot end. We will find upper bound for departure of ith customer in the arrival array. Then what we would do, after finding the upper bound, we would decrement our IT. Why? Because IT is currently pointing to the customer who arrived after the departure of this customer. But after decrementing, this will point to the last customer who arrived before the departure of ith customer. Then we would find all those customers who arrived before this ith customer. We will take a long type variable arrived before I and store IT minus dot begin plus 1, because IT minus arrival dot begin will give us the index of that customer who is the last one to arrive before I. But after adding 1 to it, we will get the count, because index is always 1 lesser. So then finally we will get our answer. We will update our max customers is equals to maximum value of either the current value of max customers or the customers who arrived before I minus I. Why we are subtracting I from it? Because these I customers have already departed. These are the customers who have arrived before this ith customer, but some of the customers have already left, which we will subtract from them. Then at last we would print our max customers. Let's test it for the base case. We made a small blunder. We haven't took inputs for arrival and departure. For int I equals to 0 is lesser than n, I plus plus c input arrival of ith customer and departure of ith customer. I hope now it works all right. Now it's working fine. Let's try to submit it. Problem number 5. Our solution has been submitted successfully. If you still have any doubts or queries, you can ask them in comment section. Thank you everyone. We will meet in the next video.